Trig and Precalc, hello. As promised, I said I would go over number 2 and how to solve it and get this answer on a little video, so that's what this is. So number 2, you sit hovering in your custom helicopter over Lake Winnetonka. The distance between the opposite sides of the lake is known to be 1555. The angle of depression out of one side of your chopper is 19 degrees, and the angle of depression out of the other side is 42 degrees. How high are you hovering above the water? It's tough. This is a tough problem for sure, but I'll go through it step by step. You have to make a little system of equations, or the way I'm doing it. There are other ways of doing it, but this is the way I prefer. So always start with a picture just to kind of figure out where are those right triangles coming in. So there's Lake Winnetonka. Our copter is somewhere above there. We don't exactly know where, but I'll just put it in the middle. When I was little, someone told me to draw a spoon if you ever want to draw a helicopter. So there's my spoon helicopter. Angles of depression. You start for any angle of depression or elevation, you always start by going off into the horizon. And then for angle of elevation, you would swing up, and that's the angle we're talking about. But for angle of depression, you swing down. So when it says 19 degrees to one side of the lake, the angle they're talking about is this angle, which would in turn give us a triangle that looks something like this. Okay, out the other side, so here is the horizon this way, we're going to swing that down to get to this side of the lake, and I think it said the other one was 42 degrees. So we have our right triangle right here. Okay, the last piece of information they told us was that the lake itself, from here to here, is 1,555 feet. I'm going to put that up here. 1,555 feet across. Okay, it's not a lot of information, right? When all these problems with SOHCAHTOA, we normally have an angle and at least one other side, and we don't. We have this relationship between these adjacent sides that this one plus this one will equal 1,555, but we don't exactly know what each one of these is. We don't exactly know where the helicopter is above this water. Okay, we're trying to find H, which will be the same for both of them, how high it is. The method I choose to make this happen is I'm just going to make a new variable, right? We just talked about a second ago that we need another piece of information in here, another side of the triangle. So I'm going to use, since I know all the way across is 1,555, it should probably be these two sides. I'm going to start by calling one of them just an x. And if the other one's x, a lot of us want to say, well, then this one has to be y. But we don't want to introduce a new variable. We want to use x as part of our description over here for this side of the triangle. If I know all the way across is 1,555, and I know this piece is x, then this piece will just be the difference between those two. It's just going to be 1,555 minus x. So now we have two right triangles. We have two equations we're going to write, and that's good because we have two unknowns, right? A system of equations, if you have two things you don't know, you need that many equations to figure them out. So at the 42, this is opposite, this is adjacent, that's tangent. Tangent 42 equals h over x. On the other one, opposite, adjacent, tangent again. Tangent 19 equals h over 1,555 minus x, okay? And if we go back into our Algebra 2 brains, a system of equations, we usually use substitution or elimination. Elimination doesn't look right here. Elimination is when we had the variables over top of each other. We could just cancel them out. This thing is made for substitution. So I need to solve for one of these variables and then substitute it into the other equation. Pretty easy over here. If I just multiplied x to the other side and got x times the tangent of 42, I would have h by itself. And I can substitute. I know what h is. H is x tangent 42. So I'm going to substitute that over here for the other h. Tangent 19 equals some fancy algebra here. H, which is actually x times the tangent of 42, all over 1,555 minus x. And those of you paying attention at home, there was a reason I gave you the bell work I gave you a couple days ago. I patterned a problem right after this one. There was one that looked just like this without the tangents and things, but solving this algebra problem, not easy. Next step, I'm going to multiply. This whole thing says divided by 1,555 minus x. I can't solve for x if it's down here, so I'm going to multiply this out of this denominator and move it to the other side. So it looks like 1,555 minus x times the tangent of 19 equals x times the tangent of 42. A lot of you guys, you don't have to carry these tangents with you. You could jam those in your calculator and turn them into decimals, but we lose a little bit of accuracy every time we do that. So I'm a nerdy math teacher. I'm just going to keep going, and I'll type it all in my calculator once at the very, very end. Okay. From here, I need to do the distributive property. It will be 1555 times the tangent of 19 minus x times the tangent of 19 equals x times the tangent of 42. Just distributed. Now I need to gather all my x's. I have some x's here and I have some x's here. Well, we need to gather them up. So this says minus x tangent 19. I'll add that to the other side. 1555 tangent 19 equals x times the tangent of 42 plus x times the tangent of 19. From here, I'm going to factor. Yeah, it's been a while, but we need to know how to do it. I'm going to factor. These both have an x in common, so I'm going to factor an x off of them. You can get tangent 42 plus tangent 19. This is a doozy for sure, but you guys can do this. You got the skills. Okay. Final step then to solve for x is just to divide this whole thing to the other side. And I made the mistake. I was going over my key with Mrs. Gondor, and I was thinking I was done. I got this. I jammed my calculator. All done. But there's something wrong with that. Hopefully you can figure out what I did wrong. I mean, I got x by itself. Usually that's enough, right? Well, it's not. What are we solving for? Let's go back to the problem. Let's not get lost in the forest here. X is it's trying to figure out where it is on top of the lake somewhere, left and right. H is what we wanted to know. We want to know how high off the ground is this helicopter. Man. So to do that, I'm going to go back substitute. We have this equation right here. H will be whatever x is times the tangent 42. Okay, well, we have what x is. I just need to times that by a tangent 42. So my final expression here will be 1555 tangent 19 times that tangent 42 we just talked about, all over the tangent of 42 plus the tangent of 19. Whoa! Jamming all that into our calculator. That will be the height of this helicopter. I'd already done it once, so there's the answer, but pretend like you can't see that. I'm going to do parentheses at 1555. Tangent of 19, close it. Tangent of 42, close it. Close it. Divided by, I'm going to start a new one. I'm going to say, hey, I want all this in my denominator. Tangent of 42 plus tangent of 19. Close that off. 387, about equal to 387.3 feet. That's a tough one. I'm not going to lie. That's one of the hardest ones you'll get as far as SOHCAHTOA is concerned. So hopefully you can follow that, and if something similar happens, you could handle it. All right, Trig. See you on the flip.